Well, hello guys, welcome back from Thanksgiving break. Hope you guys all had a wonderful week and you rested. We're going to go ahead and start off with lesson 4.3, dividing polynomials. Now remember, before the break we did adding, subtracting, and multiplying polynomials. So it kind of makes sense that we're doing division of polynomials today. We're going to look at two different ways to divide polynomials. The first one is through long division, and the second one is called synthetic division. Long division can be used for any two polynomials that you're dividing, absolutely any of them. And synthetic division is only used for a specific case. When you're dividing by a particular type of binomial. Okay, so we're going to take a look at that. But before we do, let's take a look at just long division in arithmetic. So this is kind of a flashback to maybe, I don't know, 5th grade. Let's say you have this number. Let's make it large. Okay, 1,357,696. And I'm asking you to divide it by 2, not using a calculator. Okay, so the way we normally do division is we look at the 2. We're going to look at the 1. 2 doesn't go into 1, so we can't divide that. So we look at the 13, and 2 will go into 13 6 times. Notice that the 6 goes over the 3 in the 13. 6 times 2 is 12. We subtract. You get 1 and you bring down the 5. Okay? 2 goes into 15 7 times. 7 times 2 is 14. You're going to have a remainder of 1. Bring down your 7. 2 goes into 17 8 times. 8 times 2 is 16. Subtract, you get 1. Bring down your 6. 2 goes into 16 8 times. 8 times 2 is 16. Subtract, you get 0. Bring down your 9. 2 goes into 9 4 times. 4 times 2 is 8. Subtract, you get 1, and bring down your 6. And once again, 2 goes into 16 8 times, and 8 times 2 is 16. You subtract, you get 0. Now this number down here, we call it the remainder. Okay, in this case, the remainder is 0, which means that the number 1,357,696 is divisible by 2. It has a factor of 2 and a factor of 678,848. Okay, that's for when we have a remainder of 0. We can then say, okay, these two numbers are factors. All right. So that was in arithmetic. Let's go ahead and take a look at this with polynomials. So let's say this is the problem. Divide 2x to the 4th plus 3x to the 3rd plus 5x minus 1 by x squared plus 3x plus 2. The very first thing you need to do is to check each of the two polynomials that you're going to be doing. This is a polynomial. This one's a trinomial. This one has 3 terms. This one has 4 terms. Remember, anything with 4 terms or more is just called polynomial, but they're technically both polynomials. Okay, this is just a specific type called a trinomial. The first thing you want to do is to make sure that all of your variable terms are represented. So what does that mean? If you look over here, this is an exponent of 4, this is an exponent of 3, this is an exponent of 1, 5x to the 1st. 1 is a constant, so it technically has an exponent of 0. This is the same as minus 1 x to the 0. So if you look, we've got 4, 3, 1, 0. We are missing the second degree. All right, so when that happens, you're going to have to create that term using 0. So this is really 2x to the 4th plus 3x to the 3rd plus 0x squared plus 5x minus 1. We need to put that there. If not, this will not work. Trust me. All right, we're going to check here. Here we have a 2, we have a 1, and a 0. So 2, 1, 0, we're good. We've got it. Okay. If this was 4 terms or 5 terms, we would have 5, 4, 3, 2, 1, 0 as far as exponents for the x. But since there's only 3 terms, you just need 2, 1, and 0. All right. We're going to go ahead and get ready to divide this. So let's set this up. Over here on this side, we are going to put x squared plus 3x plus 2, and this goes under here, 2x to the 4th plus 3x to the 3rd plus 0x squared plus 5x minus 1. All right, we're ready to go ahead and start now. So in order to divide this, you're going to look at the first term of this polynomial and the first term of that polynomial. And you're going to say to yourself, what do I multiply x squared by in order to get 2x to the 4th? So what do I multiply x squared by to get 2x to the 4th? Well, your answer is going to be 2x squared, right? X squared times 2x squared is going to be 2x to the 4th. So we're going to use this 2x squared, and now where we place it is also very important. We're going to go to the x squared term, which is right here, and then right above it we put the 2x squared. Okay? And now we're going to go ahead and multiply 2x squared by x squared, by 3x, and by 2. In other words, we're distributing 2x squared to each term. So 2x squared times x squared, that's 2x to the 4th. 2x squared times 3x, that's 6x to the 3rd. 2x squared times 2, that's 4x squared. All right? And now, just like we did in the divisions up here, we're going to perform a subtraction. The easiest way to subtract here is basically just take the inverse sign for each of the terms down here. So if it's a positive, like here it was positive 2x to the 4th, it's going to become negative. If that's a positive, it's going to become negative. If it's a positive, it's going to become negative. Obviously, if it was a negative, you're going to change it to a positive. So you're just taking the inverse of all the signs. And if you did this correctly, these two terms should go to 0. So 2x to the 4th minus 2x to the 4th, that's going to give you 0x to the 4th, which is exactly what you want. And then you have 3x to the 3rd minus 6x to the 3rd. That's going to be minus 3x to the 3rd. And here you have 0x squared minus 4x squared. So that's going to be negative 4x squared. And just like in the example that we did with arithmetic and division, we bring the next term down. So I am bringing down this 5x. Okay? Now I am going to look still at that x squared, but at this particular term, the one that's over here. So x squared times what gives me negative 3x to the 3rd? Well, that's going to be negative 3x. Please note that the x has to be over the x term. All right. Now we're going to take the negative 3x and multiply by x squared, by 3x, and by 2. So that's going to give me negative 3x to the 3rd minus 9x squared minus 6x. Once again, we're ready to subtract. In this case, I'm just going to flip the signs on all of these. So this will be positive, positive, positive. Negative 3 plus 3, that goes to 0, which is exactly what it should do. Negative 4x squared plus 9, that's going to give you a positive 5x squared. 5x and 6x is going to give you 11x. And here we have the last term coming down, minus 1. Okay? Excuse me. Once again, we're going to look at this x squared and this 5x squared. What do we need to multiply x squared by to get 5x squared? Well, that's a plus 5. Notice that that's a constant, so it would be right over the constant. 5 times x squared is 5x squared. 5 times 3x is 15x. 5 times 2, that's 10. Once again, we're going to subtract this bottom polynomial, so that means if it was positive, it's going to become negative here, negative there, and negative there. And we go ahead and add these now. That goes to 0, which is what we would expect. We have 11x minus 15x, that's negative 4x. We have negative 1 minus 10, which is negative 11. And just like we did this part here, where we got to the very end and we had, in this case, a remainder of 0, this is also your remainder. Okay? And the way we're going to write, this is the remainder, the final answer, I don't know why it's so bright there. Sorry about that, guys. The way we're going to write the final answer is we're going to get this answer from up here, which is 2x squared minus 3x plus 5. And we're going to do a plus. We're going to put the remainder. The remainder is negative 4x minus 11. But just under just the remainder part, you're going to put what you divided by, and you divided by x squared plus 3x plus 2. So this is your final answer. Okay? Now, this might not look familiar to you, but for example, let's say we had 19 divided by 2, right? 9 times 2, that's 18. We have a remainder of 1, okay? Back in, I don't know, 5th grade, you probably wrote 9, remainder 1. But then you learned that you can rewrite this as 9, this is your remainder 1, and what you were dividing by, 9.5. And that's a lot more useful for us than, sorry about that, than 9 remainder 1. It just is, we get more information here. I like this one better because we know what we were dividing by. Okay? And that's exactly what we're doing here, right here. We're putting the remainder over what we were dividing by. All right, moving on. Let's do 2 more like this. So here we're going to have like a little U try. So I'm going to write both of them down, and you can pause the video, try to do them on your own, following the same steps that we did at the beginning of the lesson, and then you can turn on the video and see if you got it right. So these are your 2 problems. And again, we're doing long division with both of them. So I'll give you a few seconds there, a few minutes to go ahead and work on it. So go ahead and pause the video and come back when you're ready. Okay, so hopefully you got a chance to do this. Again, the first thing we're going to check is to make sure all our terms are here. This is x to the second, x to the first, and this is a constant, which is the same as x to the 0, so we're good there. This is x to the first, and this is the same as x to the 0, so we're good here. We're going to go ahead and put the x minus 3 over here. We're going to put 2x squared minus 5x minus 3. All right, so we're going to look at the x and the 2x squared. X times 2x will give me 2x squared, so the 2x, remember, goes right above the x term. We're going to go ahead and multiply 2x times x, that's 2x squared. 2x times negative 3, that's minus 6x. And now we're going to subtract. Remember subtraction, the way I do it, just change the signs down here and you're ready to go, and then just add. So 2x squared minus 2x squared should go to 0, which it does. Negative 5x plus 6x is just x, and bring down the next number. X goes into x one time. 1 times x is x, and 1 times negative 3 is negative 3. Again, we're going to subtract, so this becomes negative, this becomes positive, and that goes to 0, that goes to 0. That means that our remainder is 0. So that means that 2x plus 1 and x minus 3, those are factors of this guy, okay, because your remainder is 0. Let's take a look at number 2. Again, make sure you have all your terms, 2, 1, 0, 1 and 0, perfect. So this is 4x squared minus 7x minus 11 right there, and we have x plus 1 out here. So once again, we're looking at the x and we're looking at the 4x squared. So x times 4x is 4x squared, so 4x times x, that's 4x squared. 4x times 1, that's 4x. Go ahead and subtract. This becomes negative. This becomes negative. That goes to 0. Negative 7 minus 4, that's negative 11x. And bring down your minus 11. X times negative 11 is going to give me negative 11x. So negative 11 times x, negative 11x. Negative 11 times 1, negative 11. Go ahead and subtract. Remember, that just means flipping these signs. That goes to 0, that goes to 0. My remainder is 0. So here also, these are factors for x minus 11 and x plus 1. Those are factors of this guy. If you FOILed this and simplified, you should be getting that. Okay? So that was long division. And again, long division is used for any two polynomials. It doesn't matter the lengths. You can divide any two polynomials using long division. Now, synthetic division is different in the sense that it has a restriction. It is a shortcut for dividing polynomials because it only works when what you're dividing by is a binomial. So it has to be only two terms, and it has to be of the form x minus k. So that means your coefficient here has to be a 1. It can have two terms, but this has to be an x to the first. This has to be a 1, and yeah, so those are your restrictions. So again, long division you can use for anything. Synthetic you only use for this special case. So let's do an example of a special case where synthetic can be used. So if I ask you to divide this, by x minus 3. In order to figure out whether I can use synthetic or not, I have to look at the by part, right? What am I dividing by? It has to be a binomial, two terms. It has to be an x to the first power, which it is. There's nothing there, good. And it looks like that. It's in that form. Now, the next thing we need to do, like anytime you divide, is to make sure you don't have any missing terms. Here we have 3, 2. Oh, we're missing an x to the first. So we have to fix that. This is negative x to the third plus 4x squared plus 0x plus 9. All right, so make sure it is completely filled in. All of your terms are there. Now what you do for synthetic, you're going to put like a little, I call it like a half square kind of thing. It's like a little corner here. And what number that's going to go there is the opposite of what you see here. You see an x minus 3, so you are going to put a positive 3. All right? And then you are going to take the coefficient of each of these terms. The coefficient here is a negative 1. The coefficient here is a positive 4. The coefficient here is a 0. Now remember, even though 9 is a constant, it is also a coefficient because this is 9x to the 0. X to the 0 power is just 1, so we normally don't write it. But 9 is also a coefficient. All right? Then you draw yourself a little line and you're ready to get started. What you're going to do, the first number, you just bring it straight down. Don't do anything to it. Just slide it on down. Once it's here, you're going to multiply negative 1 times 3. That's going to give you negative 3. 4 minus 3, that's positive 1. Then you're going to take this number and multiply by the 3. 1 times 3 is 3. Again, 0 plus 3, 3. And finally, 3 times 3, 9. And then 9 plus 9 is 18. All right? So the division part is actually done. Now, what do these numbers mean? Well, these are going to be coefficients and remainders, depending on whether you have some or not. So let's just take a quick look up here. We are dividing a polynomial, and we're just going to look at the first term, whose initial term is negative x to the third. And we're dividing that, I'm just looking at the first one, by an x term. And we can ignore the minus for now. If I divide x to the third by x, I'm going to get x squared something. So that tells me that when I divide this long thing by this, my answer should start off with x squared. Okay? The x to the thirds are gone. So this negative 1 is going to represent negative 1x squared. This 1 is 1x. This is your constant, 3. And what do you think that is? Well, if you said remainder, you're right. That's your remainder. So to write the remainder, we would write plus 18 over, now you still have to go back and use this thing, so x minus 3. All right, so this is the answer to that division problem. All right, okay. Let's go ahead and do another one where you get to do synthetic division. All right, this one's example 3 from your book. We have divide negative 9x to the third minus 2x squared plus 2x minus 5 by x plus 1. Again, the few things that we need to check, that this is a binomial, which it is, and it's x to the first power. Remember, it has to be in that format. And that just means that when you go put this in the little half square, you're going to take the opposite of whatever's in there. So in our case, we're going to put here a -1 because it's the opposite of a +1. The next thing you want to make sure of is that all your terms are here. 3, 2, 1, and this is x to the 0, so we're good. So now we're going to just bring down the coefficient of each term, and we're ready to begin. So this guy goes straight down, -9 down here. -9 times -1, that's going to give us a +9. -2 plus 9, that's 7. 7 times -1, that's -7. 2 minus 7, that's -5. -5 times -1, that's +5. And -5 plus 5, that goes to 0. Once again, here you have an x to the 3rd, and you're dividing it by an x to the 1st. Again, we're just looking at that first term in both of them. So that means our answer should start off with x squared something something something. So this is going to be -9x squared plus 7x minus 5. And the 0, you guessed it, is your remainder, and we don't need to write it or anything. We're done. So this and these two, this trinomial and this binomial, are factors of that polynomial up there. Okay? Now there's also something pretty cool. We're going to get into something called the remainder theorem. And this is where we end our lesson. And what the remainder theorem says is that we can, if we are dividing here, for example, we're using x plus 1, which means we're dividing by -1, right? This answer, this remainder that we get, is going to be the same answer that you would get if you used, if you got a -1 and you plugged it in for x up here. So what does that mean? You know how when we do evaluates, where I say evaluate this at this value, and sometimes it's a pain? Well, if you have this situation, you can do the division, and when doing the division, whatever remainder you get is actually your answer. So let's do this. -1 to the 3rd, that's -1. -1 times -9, that's +9. -1 squared is 1. 1 times -2, that's -2. Again, I don't know about this glare. 2 times -1, that's -2, minus 5. So let's see. 9 minus 2, that's 7. 7 minus 2 is 5. 5 minus 5 is 0. So if I plugged in a -1 up here for x, I'm going to get 0. The exact same answer that I would get if I divided that polynomial by -1. That's pretty cool. And that is the remainder theorem. So let me just write it out. If a polynomial f of x is divided by x minus k, okay, then the remainder is actually the function evaluated at k. So taking the value of k, putting it into the function, plugging it in, is going to give me the remainder. That's pretty cool. So synthetic division, and you'll see this in big ideas, can be used to evaluate a polynomial And I'm going to do an example. Let's do an example of when we would use something like that. Okay, so and I'm making this up on the fly, so let's say f of x equals 5x to the third plus 4x squared plus 2x plus 7. And I want you to evaluate when x equals, I don't know, 52. Now normally the way you would have to do this is you would have to put a 5 here, 52 to the third, plus 4, 52 squared, plus 2 times 52, plus 7. That's a lot, all right? If you want an option, and again, all we're doing is giving you an option, you can do it this way. You can go ahead. Notice that this is a polynomial. All the terms are there, 3, 2, 1, 0. So I'm going to just put the coefficient. And here x equals 52, so we don't take the negative. That is actually what x is equal to. And we're going to go ahead and divide. And when we get our remainder, that's going to be the same answer as whatever this monstrosity is right here. All right, so let's try it. We bring this guy down. This is 5. We're going to multiply 5 times 52, and that's going to give me 260. Here's 260 plus 4, 264. 264 times 52. That's going to give me 13,728. Plus 2, that's 13,730. Multiply 13,730 times 52, and that's going to give me 713,960. Sorry about that, I have to add that 7. We're going to add the 7, and that's going to give me 713,967. And this should be the same answer that I get up here, 713,967. We can check it because I know you don't believe me. So 52 to the third power, that's a lot. Let's see where I can put this. This is 5 times 140, 608, and 52 squared, that's going to be 2704, and 52 times 2 is just 104, plus 7. So then we're going to multiply 140,608 by 5. I'm going to do it over here because I've run out of space. 703,040. And we're going to multiply these two. 2704 times 4. And that's going to give me 10,816. Plus 104 plus 7, and now I'm crossing my fingers because I made this up and I hope I did it right. If not, gotta go back and see where I made a mistake. So I'm adding all this stuff up, and we are getting 713,967. Yay, we got the right answer. All right, so again, this is just an optional way of evaluating polynomial functions. Again, it's when you have the specific value like this, and you can just do the division. You can do it synthetically, and sometimes it's faster, sometimes, I don't know. It might not be, but generally it should be faster, especially with weird numbers like this or bigger numbers. Okay? And that, guys, is the end to this lesson. I'll see you next time for lesson 4.4. Have a good day.